Hello statistics student, this video is for chapter 4.3 binomial distribution part 3. We are looking at some more examples on finding probability of something that can be modeled by binomial distribution. And in particular, we want to actually look at what is the use of finding the non-significant range and using the parameter mean and standard deviation. So last time we were looking at finding probability of someone, what are we doing? 24 people, I think. It was 24 customers. And then the bookstore manager knows that for all of the customers that walks in, about 9.5% of them would buy books. And then we want to figure out what is the mean number and what is the standard deviation in this X binomial distribution. So we already have entered it into statistics. N equal to, we model it by N equal to 24. Right, so in our case, N equal to 24, and then probability of one success is 0.095. So we have this set up here, 24.095 p, and then we are not looking at any X. We have done a few questions on this. Now we look at the mean and standard deviation. So it turns out that the mean is here underneath the sample editor. Mean is 2.28, so we can round it as 2.3, and the standard deviation is 1.44. So mean is 2.3, standard deviation is 1.44. So what is a normal range? When I say, like, usually what would I see? On average, there will be out of 24 customers, 2.3 customers will buy books. But what is, still something that is usually that we see, I'm not surprised that you will see that. It is mean is always mean minus 2 standard deviation and mean plus 2 standard deviation by, this is minus. So we get 2.3 minus 2 times of 1.44. That's negative 0.58, which doesn't make sense because the lowest number we have is 0. So we can say it's from 0 to 2.3 plus 2 times 1.44 is 5.18. So from 0 to 5.1, that many customers will buy book is, you are not surprised. So this is called a non-significant range. It is something that fluctuate, sample can fluctuate like that if you have 24 customers. But if it is more than 5, like 6 or 7 customers, that is a surprise. So if this happened, it must be because of something else. And maybe you have a marketing complaint, or you a campaign, or you do some advertisements, so you have more customer coming. Okay, so that's how you can use the non-significant range to tell. I expect out of 24 customers, on average, it's 2.3 customer buy books, but it could be as high as 5 and as low as 0. And I would seldom see 6 customer or more that would buy the book. So again, these are estimate, not exactly, but they're quite good if N is big. The third applications that is quite useful in daily life would be in airlines. So airlines, usually they have a certain seat only, but they usually would, overbook, book too many, more customer, more passenger than the seat the airplane can handle. Not hoping actually, because in general, historically, some customers don't show. Either they're too late or last minute cancel or something. So let's look at an example like this. A small airline has a policy of booking as many of 60 persons on an airplane that can seat only 53. So there's only 53 seats, but they would receive booking for 60 persons because past study revealed that only 78% of booking actually arrive for the flights. So do you just look at, okay, 60, if 78 arrive, it would be 60 times 0.78 should be 46. Oh, that is plenty enough, right? So you might think that, oh, I have 53 seats, so I have plenty enough. So is it true? Because this 78% is for per customer only, right? So when you have that many all bundled together, like 60%, the total total pick of the number of passengers 60, would it still work? Okay. Can I actually increase it more so that I can, save some money or get as much money as possible? So A, find the probability that if the airline books 60%, not enough seats will be available. That means I am counting X is the passenger that arrived, right? Passenger arrive. And the chance of one arrive is 0.78. Great. So we have these two. And then not enough seats means I have 54 or more arrive. Right? X is 54 or more. So I will go to stat this. It is 60 that I book, and then it's 0.78. I want 54. Not exactly 54, but actually it's not enough if I have 54 or more. Any of these, that would not be enough seat, right? It's not 53 because 53 is, if you 53 arrive, we are exactly okay. So it's 0.013. So we would use that this n equal to 60, p equal to 0.095, but x is equal to 54 because not enough seat, that means 54 or more. And then I'll use the probability of x or greater, right? More means greater. 0.013. Find the non-significant range of passengers who arrive. So if I have 53 seats, is it safe? What are the range of passengers that would arrive? So I would need mean, standard deviation, and then I would build the 2 times of sigma, right? Mu minus 2 times to mu plus 2 times, because these are kind of generally fine. So I did it already 60.78. So when I'm doing the evaluation of these are already done 46.8 and 3.20. So we'll say mean is 46.8. SD is 3.20. So we just calculate. So 46.8 minus 2, it could be as low as that few passenger arrive, up to 46.8 add 2 or 3.2. So that would be as low as in the calculator. 46.8 minus 2 times 3.2. 46.8. Okay. 46.8 minus 2 times 3.2. 40.4. So if you book 40 people, book 60 people, it could be as low as that to what? Adding 2 standard deviation. It could be as low as 53.2. So these are the number of people that usually will come. They are all very usual. If it is higher than 53, I'm very surprised. So do we have enough seats? Yes, we have 53 seats, so it's just enough. So it's just enough to cover the usual range. So so this is how we do it. This is the range, and we normally, it is likely, right, to have enough seats. And it is unlikely. And you can see that 54 or more is 0.013. It's less than 5%. It's unlikely to have not enough, to be not enough. So you can see how it is very useful. And then you can book 60 and you can, just earn more money. Okay. Probability of, so these are the calculation. 40 to 53.2, 50.2.